Good morning, ma'am. I am Rehan Anjum. Currently, I am pursuing my second BTech in CSE department. Today, I am going to present a video on logic gates and universal gates. So let us see what are logic gates. Logic gates are the fundamentals of the digital system. Logic gates are electronic circuits because they made of number of electronic devices and components like diodes, transistors, registers. Basically, these logic gates are used in a variety of electronics like smartwatches and clocks and many more. And generally, they have two inputs. And logic gates occurs in two levels. These levels timed as active high or active low, on or off, and similarly 1 and 2. So let us see types of logic gates. There are three types of logic gates: basic logic gates, universal logic gates, and special or derived logic gates. In basic logic gates we have three types, and OR gate and NOT gate. And in universal logic gates we have two types, NAND gate and NOR gate. And in special or derived logic gates we have XOR and XNOR gates. Let us see basic logic gates. In basic logic gates, AND gate is one of its gates. AND gate performs logical multiplication operation on the inputs, and when both inputs are high we will get output as high, otherwise rest of the outputs are low. Boolean expression of AND gate is a y equals to a into b. We can see the truth table over right side. We have when both the inputs are high, output is also high. When the both inputs are low, and we get output as low. If whenever one input and one input is low and another output is high, we will get the output as low. And let us see OR gate. OR gate performs a logical addition operation. When both the inputs are high, output is high. Similarly, when both the inputs are low, the output is low. In other words, for output to be 1, at least one input must be 1. We can see the truth table in right side. When one of the input is high and another output is low, we get the output as high. When both the inputs are high, we get output as high. When both inputs are low, we get output as low. And whenever we have in OR gate we have two inputs and one output. Now let us see NOT gate. NOT gate is called as an inverter, which can only have one input and one output. It is a device whose output is always the complement of its input. Boolean expression of NOT gate is A complement or A bar. We can see the symbol of NOT gate, and truth table is when the input is 0, we'll get output as 1, and when input is 1, and we'll get output as 0. Now let us see universal logic gates. There are two types of universal logic gates. They are NAND gate and NOR gate. NAND gate is the inverse of AND gate, and NOR gate is the inverse of OR gate. So let us see NAND gate. Basic logic is in NAND gate. Basic logic is combination of and NOT gates, and Boolean expression of NAND gate is A B bar. Whenever we see the truth table, when both inputs are low, we'll get the output as high. And when both the inputs are high, we'll get output as low. When one input is low and another output is high, then we'll get output as high. Now let us see NOR gate. NOR gate is the combination of OR gate and NOT gate, and the Boolean expression of NOR gate is A plus B bar, and the truth table is when both inputs are low, we'll get the output as high. When both inputs are high, and the output will be low. And let us see the special or derived logic gates. In these we have two types. Let us see XOR. The XOR gate is specially designed to be used in digital circuits to perform some operations. It also referred as the exclusive OR gate. The XOR gate takes only two inputs at a time and give a single output. and the output of these gate is high and logic 1 only when its two inputs are different, and the boolean expression of XOR gate is a plus b bar. And whenever we see go through the truth table, when both inputs are low, we'll get the output as low, and when both inputs are high, then also we'll get output as low. If one input is low and another input is high, then we'll get the output as high. Now let's see XNOR gate. It performs the inverse operation of XNOR gate. This is used to perform operations in digital circuits, and it is a combination of XOR and XNOR gates. When two inputs are the same, output is high. We'll see truth table. When both inputs are same, I mean when both inputs are low, we'll get the output as high, and when both inputs are high, we'll get the output as high. When one of the input is low and one output is high, then we'll get the output as 0. So that's all about the logic gates and universal gates. So thank you for this opportunity.